Okay, so in this lesson, we're going to talk a little bit more about finding the domain and range of a function. In the other lesson, we found the range of a function visually when we had the graph in front of us, but now we're going to do it algebraically. And we're also going to talk about different ways of combining functions. Okay, but before we get into that, there's this example about how do we evaluate functions from the graph. Remember that we already discussed how to evaluate functions if you have the formula. To evaluate a function if you have the formula, all you have to do is plug in. Let me see if I have it right here. Yeah. Yeah, we did that in lesson 15. So if you have a formula, right, and you're asked to evaluate the function at a number, all you have to do is plug it in the formula. And that's how you evaluate a function at a number. You just plug it in, simplify. Now we're going to do that visually if you have the graph in front of you. Okay, so here's this graph, and we are asked to evaluate the function f at 0, at 3, and at 6. Okay, this just all amounts to just looking for the coordinates of the corresponding point, the y-coordinate. So for example, to find f of 0, I look on the x-axis 0, which is right here, and then I go to the graph, which is right there, and then that point is a point where x is 0 on the graph. So the y-coordinate is the answer. The coordinates of that point are 0 and 1, 2. So the x-coordinate is 0, the y-coordinate, and the y-coordinate, y equals f of x. So their y-coordinate is 2. So that means that f of 0 is 2. Okay, now let's do f of 3. f of 3, so I look on the x-axis for 3, 1, 2, 3, and then I look at the corresponding points in the graph, which is that one right there. The coordinates of that point, the y-coordinate is 1. So that means that f of 3 is 1. The y-coordinate is 1. And lastly, f of 6. Let's see, f of 6. 1, 2, 3, 4, 5, 6. So here is 6, and then the corresponding point in the graph is right there. So that is actually also 1. The y-coordinate of both of them is 1. Okay, so that's it. That's how you evaluate a function from the graph. Just look for the y-coordinate of the corresponding uh, point. If you know x, find x. Given x, find it on the x-axis, and then find the corresponding point on the graph, and the y-coordinate is what you want. All right, let's take a look at this one. Find all x such that f of x equals -1. So this is like solving an equation. We have to solve an equation from the graph. We have to find all x such that when we plug in x in f, we get -1. Okay, but f of x, look at it from that formula, right? F of x is nothing but y. So that means we have to look for all the x's for which the corresponding point on the graph is -1. I mean the y-coordinate of the corresponding point on the graph is -1. So now the y equals -1 is right here. So look at all the points that have all the points on the graph that have y-coordinate -1. Well, there's only one, right? If you imagine the horizontal line, it only crosses the graph here. There's only one point on the graph that has y-coordinate equals -1. Only one, and it is that one. So what is the corresponding x for that? 1, 2, 3, 4. -4. So that means that x equals -4. When x equals -4, the y is -1. And that's the only point that satisfies that. Okay, similarly for this one says find all x such that f of x, and f of x is a y coordinate, find all x such that the corresponding y coordinate is 1. Okay, the y equals 1, imagine the horizontal line, y equals 1, and if you see, there's 3 points. There's that one, there's that one, and there's that one. There's 3 points that are at height y equals 1. So all of them are x equals, starting from the left, -2, x equals 3, and x equals 6. So there's 3 points whose corresponding y coordinate is 1. That one, and that one. Okay? And lastly, last question here says find the domain and the range of f. This is just what we did lesson 15, the end of that. The domain is the vertical, the horizontal span, so left and right. There's an arrow right there, so that means this graph goes on forever to the left. And there's an arrow to the right, so that means that graph goes forever to the right. If it goes forever to the left and forever to the right, the domain is going to be what? It's going to be from -infinity to plus infinity. That would be the domain. From -infinity to infinity. It goes forever to the left and forever to the right. Now, this graph actually is supposed to be a little bit like that. It goes forever to the left, but it really is supposed to be like going down. Like, let me see, something like this. It's not very clear from that graph, but it's supposed to be something like this. So that is going down a little bit. All right, now let's find the range. The range is the vertical span. So the highest, taking into account what I just said, that this after this point it just goes down. Okay, that means the highest point the graph ever reaches is right there. The highest value of y is actually going to be 2. The graph does not go higher than that. In this part, it just starts going down. That's the highest it reaches, 2. Okay, and then from below, it goes down forever below here and there. This part also goes down. So that means it goes down all the way to -infinity. It goes down forever. So that means the range is going to be from -infinity, because it goes all the way down, and then the highest it reaches is 2. So the range is going to be from below is -infinity, and then the highest it reaches is 2, and you have to include that because there's not a hole at 2. That point is included. It is filled in. All right. So that is it for page 1. Okay, now let's talk about how to find the domain of a function when it is not explicitly stated. Sometimes if they give you a function, they might give you the function what is the domain of the function explicitly. When they mean to give you the domain of the function explicitly, they're gonna write it out just like this. Remember that the notation for the function is a function from A to B, right? When they write it like this, they're giving you the domain explicitly. The domain is A. So for a concrete example, suppose you have the function, let's say from 0 to 10 to all the real numbers, and the formula for the function is x squared. In this example right here, they're telling me that the domain is from 0 to 10. That is the domain of this function f, from 0 to 10. The formula here is the rule of assignment. Given an input, how do I figure out the output? By squaring. That's the rule of assignment. The function has domain from 0 to 10. These would be the codomain. Okay, so that's one way. If you see the function written like this, that is the domain. And you don't argue that. That's it. They're telling you the domain is from 0 to 10, and that's it. End of the story. Sometimes they don't tell you explicitly what is the domain of a function. In that case, you assume that the domain is all the numbers for which the formula makes sense. All the numbers for which the algebraic expression for the formula f of x is meaningful, meaning you can plug in there and get back out a real number. That would be the domain. It is called also the natural domain or the implicit domain. So whenever they don't give us explicitly what is the domain, it is often the case that it is our job then to find it, because that helps for various things. There's a guideline, though, for figuring out what is the natural domain of a function. The guideline is go through these 3 bullet points. Now, for now, we're only going to focus on the first 2 because the third bullet point is about a topic that we have not discussed yet, which is logarithms. So for now, we only concentrate on the first 2 bullet points. Okay, so here's what the bullet points say. When I'm looking for the natural domain of a function, I need to look out for any fractions that have variables in the bottom, in the denominator. If there are fractions that have variables in the denominator, you know that you cannot have numbers, you cannot allow numbers that make the bottom 0. So that means you need to find the numbers that make the bottom 0 and discard them. They're not going to be allowed to be part of the domain. So the way you do that is you set the bottom equal to 0, you solve that equation, and those values are the ones that make the bottom 0. Those values need to be discarded. They're not going to be part of the domain. Then the second bullet point says if there are radicals of even index, remember the even index, square root, 4th root, 6th root, 8th root, 10th root, etc. If there are radicals of even index, then what is inside the radical, the so-called radicand, what is inside the radical needs to be bigger than or equal than 0. So what you're going to do then is you're going to set the the inside of the square root or radical of even index to be greater than or equal than 0, and you're going to solve that inequality. That's what you need. You need the numbers that make the inside bigger than or equal than 0, because if you allow numbers that make the inside negative, then you're going to run into imaginary numbers, right? Like square root of -2. That's imaginary. There's a complex number. So you don't want those. You want, remember, only the numbers that you can plug in. You want all real numbers that you can plug in the formula and get back a real number. That is the natural domain. Okay, so those are the only 2 bullet points that we're gonna worry about for now. Okay, so let's start with the first one. We're gonna write our answer. I'm not gonna do it for all of them, but for many of them, I'm gonna write the answer in both in stability notation and also in interval notation, because in my math lab there are some exercises in which they ask for one or the other or both. Okay, so starting with the first one, this one right here. Find the domain of that. Well, we have to go through both bullet points systematically. So starting with the first bullet point, if there are fractions, denominators, you said the denominator equal to 0. Well, there's no denominators, so that means the first bullet point does not apply. So we skip it. So now we go to the second bullet point. The second bullet point says if there are radicals of even index, which there is, then you need to set the inside bigger than or equal than 0. So we need then that 2x minus 2 is bigger than or equal than 0. That's what we need. Then we solve this, solve it. So move the 2x bigger than or equal than 2, which means divided by 2, x is bigger than or equal than 1. So that is the answer in inequality notation. Now they're asking for the answer not in inequality notation. They're asking for the answer in set builder notation and interval notation. Okay, the answer in set builder notation is going to look like this. The set of all x's, so you use a curly bracket, set of all x's such that x is a real number, and I'm not going to write that, but in MyMathLab is going to be written there for you. The set of all x's such that that bar is like an absolute value bar, but you only write one. That means such that. So the set of all x's such that x is a real number, which again I'm not going to write. X is a real number and x is bigger than or equal than 1. So that would be the answer in set builder notation. The answer in interval notation, well, I want all numbers bigger than 1, but I need to include 1, so it would be bigger than 1 means all the way to infinity. So the answer in interval notation would be interval from 1 to infinity. Okay, and that's it. That's all for that. Now let's do the other one, B. This one, first bullet point says that we need the bottom to be not 0. So the way you figure that out is you actually set it equal to 0, and then you solve that. So then if x plus 3 equals 0, that means x move the 3, x is negative 3. So that means this is a number that you do not want. So that means this number needs to be discarded. Okay, you don't want x equals negative 3. So when you write down the answer, and by the way, you're supposed to check always, don't forget any of the bullet points. You're supposed to check the second bullet point. The second bullet point is if there's radicals of even index, then do this. There's no radicals of even index, so the second bullet point does not apply, so that means we're done. But don't forget to check both always. Okay, so you don't want negative 3. You don't want negative 3. So if you draw the picture of the real line, you want all numbers, you want this, and you want that. You want all numbers except negative 3. Okay, now the answer. In set builder notation, you want to set up all x's such that x is a real number, which I'm not going to write. It's too long. X is a real number, and x is not 3. Oops. Okay. That is the answer for that. And now in interval notation, the real line is broken up into two pieces, from minus infinity to 3, and from minus infinity to negative 3, and then from negative 3 to infinity. So you have two pieces, you have to put them together with a union symbol. It's going to be from minus infinity to negative 3, parentheses because you don't want to include the 3, negative 3, union negative 3 to infinity. Okay, and that's the answer in interval notation. Now let's look at C and D. C says f of x equals absolute value of x minus 10. First bullet point, if there's any denominators that have variables, set the bottom equal to 0. Well, there's no denominators, so that means the first bullet point does not apply. And now, second bullet point is if there's radicals of even index, then blah blah blah. Well, there's no radicals of even index, so that means the second bullet point does not apply either. So that means there's no issues. All real numbers work. There's no issues. All real numbers work. So that means the domain is everything. So from minus infinity to infinity. And that makes sense because you can really plug in anything that you want in there. You can find the absolute value of any number whatsoever. There's never going to be a problem. No number needs to be discarded. All numbers work in there. So the domain is minus infinity to infinity. Okay, and lastly, D for this page. There's more on the next page. For D, again, follow the guideline, both bullet points. First bullet point, if there's the denominators, set them equal to 0. Well, there's no denominator, so the first bullet point does not apply. And then, if there's radicals of even index, blah, 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 well, there's no radicals of even index, so that means there's no issues. Nothing has to be discarded, so the domain is everything again. And once more, that makes sense because you can literally plug in anything you want in this formula. There's no issue. Any number that you can think of, you can plug it in there, and that makes perfect sense. There's no issue at all. Okay, continuing on the next page with a few more examples. What is the domain of this? The natural domain? Well, going through the bullet points, there's no denominators, so first bullet point does not apply. And second, there's no radicals of even index, so the second bullet point does not apply either. So that means there's no issues with any real number. No real number has to be discarded. The domain is everything. So the domain is from minus infinity to infinity. That's always going to be the case for every polynomial. The domain of any polynomial is all real numbers, from minus infinity to infinity. Using set builder notation, that's going to look like this. Set of all x's such that x is a real number. Okay, now let's look at f. Okay, f. First bullet point, if there's denominators, set the denominator equal to 0. There's no denominators, so that means first bullet point does not apply. Second bullet point, if there's radicals of even index, well, there's no radicals of even index here because that's a cubic. So that means the second bullet point does not apply. So actually then, that means the domain of this is everything. Okay, now let's look at G. G. Okay, go through both bullet points. notice that the second bullet point is not going to apply because the second bullet point is about square roots of radicals of even index. There's no radicals of any even index, so that means the second bullet point is not going to apply. So only the first bullet point applies here. There are fractions. There's a denominator here that has variables. So that means we need the denominator to be not 0. It cannot be 0 because any number if it is 0, then that doesn't make any sense. But the way you do this is like you do the opposite, right? You set it equal to 0, and then you're going to solve that equation. Okay, the way this factors, you can use a quadratic formula or you could just factor it. These factors is x minus 7, x plus 3. So that means x equals, then you set each one of them equal to 0. Once you factor, you set each of the factors equal to 0. So that means x equals negative 3 or x equals 7. And of course, what that means is that these are the numbers that make the bottom 0. So that means you cannot use them. You have to discard them. X cannot be negative 3. X cannot be 7. Those numbers are not going to be part of the domain. You don't want those numbers. Discard them. So then, the domain in set builder notation is going to be the set of all x's such that x is a real number, which I'm not going to write there. X is a real number and x is not 3 or 7. Okay, so that's the answer in set builder notation. In interval notation, for interval notation, you should draw a picture. It's going to help. Draw the real line. So you're going to discard negative 3 and discard 7. So these are the only two numbers that you do not want. Everything else you do want. So that means you do want all of these numbers. You want that, you want that, and you want that. So you see the real line is divided into 3 pieces. So that means when you write this in interval notation, you need 3 intervals. 1 interval for each of those pieces. So that means the answer in interval notation is going to be this piece, which is from negative infinity to negative 3, parentheses, because you don't want that, union from negative 3 to 7, union from 7 to infinity. Okay, so that would be the answer in interval notation. Again, the second bullet point does not apply. Did not apply. Okay, we have 3 more. Let's look at H. H and I are very, very similar. So let's do H. In this one is a combination of both bullet points. In this one there's both bullet points apply, and this is the first one that we're doing for which both bullet points apply. So we need for this one, we need that first bullet point, the bottom is not 0. So x squared minus 5x plus c cannot be 0. So then that means you set it equal to 0. And then you solve that. This one actually factors. You can use the quadratic formula. Factors is x minus 3, x minus 2. So that means x equals 3, x equals 2. These numbers need to be discarded. These are the numbers that make the bottom 0. So you don't want those numbers. You don't want them. Okay, and that concludes the first bullet point. The second bullet point says if there are radicals of even index, which there are, that one, then whatever is inside the radical needs to be bigger than or equal than 0. So you set to the inside bigger than or equal than 0, and then you solve this. Solving this gives us 4x bigger than or equal than 2, moving the 2, and then divided by 4, x is bigger than or equal than 2/4, but 2/4 is the same as a half. Okay, so we need this. We need the inside to be bigger than or equal than 0, which means that we need x to be at least a half. Okay, now let's write down the answer in interval notation. So I'm going to draw the line. And then let's say this is a half. I'm drawing it as a filled in dot because that's included. I'm not going to discard that. So this is a half. And then I need to discard 2 and 3. So 2 is a hollow dot, 3 is a hollow dot. 2 and 3. Okay, so then I want, this is what I want. I want all numbers bigger than or equal than a half. So that means numbers that are less than a half, I do not want. I do not want numbers that are smaller than a half. So that means these numbers to the left, which are the smaller ones, cannot be used. They're not part of the domain. You cannot use those. You have to discard them. And then you want everything else except these two. So you want this part, you want that part, and you want this part. So that means there's 3 pieces in the answer, 3 intervals. So the answer is going to be a half with a bracket because it's included to 2 union from 2 to 3 union from 3 to infinity. That's the answer for that one. Okay, at this point, if you understood that, you should really pause the video and do this one. It's very similar. Okay, let's do it. For this one, again, go over both bullet points. So we need, in the first bullet point, the first bullet point is if there's fractions set that the the denominators cannot be equal to 0. So that means x squared minus 16 cannot be equal to 0. And then to figure that out, you do the opposite. X squared minus 16, you set it equal to 0. And that means x squared equals 16. Take squared on both sides. X equals square root of 16, which is 4. But remember that when you take square root on both sides of an equation, you put plus or minus. These two numbers are the ones that make the bottom 0, so you don't want them. These need to be discarded. And that concludes the first bullet point. Second bullet point, if there are radicals of even index, the inside of the radicals needs to be non-negative, meaning bigger than or equal than 0. So we need to set 3x minus 9 bigger than or equal than 0. And this gives us 3x bigger than or equal than 9. And dividing by 3, that means x is bigger than or equal than 3. So we need that. Okay. Now let's write down the final answer. So draw your line. You don't want -4. You do want 3 is included. You don't want +4. Okay, now let's see. This one right there says that all the x's have to be 3 or bigger. 3 or bigger. You cannot use numbers that are less than 3. If you cannot use numbers that are less than 3, that means this side of, you cannot use any of this. All of that needs to go. You cannot use that. X has to be bigger than or equal than 3. So that goes. So that means you want now all numbers bigger than or equal than 3. So that means you want this. You cannot use 4. 4 still needs to be discarded. And you want that. You want all numbers bigger than 3 except 4. So the final answer is going to be 2 intervals. There's 2 pieces right there. So you want from 3 bracket, because that's included, to 4, union from 4 to infinity. Okay, and the very last one. Let's go through both bullet points. We need first bullet point says x squared minus 5, which is the bottom, should not be 0. And then to figure that out, you do the opposite. You set it equal to 0 and solve that. Well, solving this gives x squared equals 5. So that means x equals plus or minus the square root of 5. Now these are the numbers that make the bottom 0. So those need to be discarded. Okay. So that takes care of the first bullet point. Second bullet point says if there are square roots of radicals of even index, set them bigger than or equal than 0. Well, there's no radicals of even index, so that means the second bullet point does not apply. So that means we're done. So when we write the final answer, this is the only thing that needs to happen. I need to discard square root of 5, negative square root of 5, and square root of 5. So when you write the answer in set builder notation, is going to be the set of all x's such that x is not square root of -5 or square root of 5. You might be able to write them together just like this with a plus or minus sign. So that's the answer in set builder notation. In interval notation, you see there's 3 pieces. You want all numbers except those 2. So you want all of that, all of that, all of that. So that means in interval notation, the answer is going to be from minus infinity to negative square root of 5 union negative square root of 5 to square root of 5 union square root of 5 to infinity. And that's the answer in interval notation.